Hello, distinguished viewers all over the world. Welcome to Simplified Maths class once again. I am your host, Mr. Mike Omini, and Simplified Maths, it has always been. Today, our topic is coordinate geometry, and the aspect of coordinate geometry we'll be taking today is midpoint of a line and distance between 2 points, the distance of a line. All right, so without waste of time, before we proceed, if you have not subscribed to our channel Simplified Maths class, please kindly do that by clicking on the rest subscribe, and God bless you as you do that. All right, so midpoint of a line. The coordinates of the midpoint of the line segment joining P1 and P2 is given as follows. So anytime we want to find the midpoint of a line, the coordinates will be x of m will be given as x2 plus x1 all over 2, and then y of m will be given as y2 plus y1 all over 2. So when we want to find the coordinates that will form the midpoint of a line, we have to do this. All right, so let's take an example. The example might come this way. Find the coordinates of the midpoint of the line segment joining, let's say, A, 2 and 5, and B, minus 1 and 3. All right, so we want to find the midpoint of the line segment joining this and this. It's so simple. When you want to find the midpoint, all you need to understand that the point here is x1, y1, and this point here is x2, y2. You have to understand that so that you can get your x of m, which is x2 plus x1 divided by 2. x2 plus x1 divided by 2. So our x2, of course, is what? 3. Oh, sorry, minus 1. So you have minus 1 plus x1, which is 2, all over 2. So 2 minus 1, you're going to have half. 2 minus 1 is 1 all over 2. So you're through with the x coordinates. So you need the y. Y of m will be y2 plus y1 divided by 2. And our y2 is 3 plus y1 5 divided by 2. And of course, you're going to have 8 all over 2, which is 4. Therefore, the midpoint, which is represented as x of m comma y of m, will be our x of m give us half, and our y of m gave us 4. So this is the midpoint of the line segment joining A and B. What does this mean? It means that, okay, if we take point A and point B, and map it on space, this is point A and point B, and we join the 2 points together forming a straight line. It therefore means that halfway between A and B, will have the coordinates half and 4 for x and y respectively. That's what it means. As long as A has the coordinates 2 and 5 and B has the coordinates minus 1 and 3. All right, this is 2 and 5 and this is minus 1 and 3. As long as these are the 2 coordinates, the only coordinate that will be exactly halfway between A and B will be half and 4. That's the meaning of the midpoint of a line. And of course, if you plot A and B on a graph sheet, and then you look for these coordinates, and you use your ruler to measure from here to here, it will give you the same thing as from here to here. Take note of that. Please take note. And again, if you find the distance between A to this point and record, it will give you exactly the same thing as the distance between this point to this point, using the distance formula which we are about to proceed on. You will get the same result. That's what it means. All right, so this is just how we find the midpoint of a line. Without waste of time, we are going straight to the next part, which is the distance between 2 points, or the distance of a line. Please take note, distance. So how do we get the distance of a line giving 2 points that are mapped on space. All right, so the distance of a line, or the distance between 2 points. The distance between 2 points. The distance between 2 points, say P1, which is x1, y1, and P2, which is x2, y2, mapped on space, is given by the formula. All right, so anytime we want to find the distance between 2 points, the formula is simple. The distance from P1 to P2 is given by the formula, the square root of y2 minus y1 all squared plus x2 minus x1 all squared. So that's how you simply get the distance between the points. All right, for instance, we can be asked to find the distance between 2 points. All right, let's do that. Find the distance. Find the distance between the points A and B. Given that we want to find the distance between A and B, given that A is this and B is this, how do we find the distance? This time around, we want to see how we can find the distance between 2 points that are mapped on space, meaning that if you use a ruler to measure A to B, what will be the distance? How do we calculate that? All right, we have said that the distance from A to B is given by the formula, the square root of y2 minus y1 all squared plus x2 minus x1 all squared. All right, so this will be the square root of, we simply want to find the distance, y2. What's our y2 here? 3. 3 minus y1, our y1 is 5, all squared plus x2. What's our x2? Minus 1 minus x1. x1 is 2. Please take note of this. x2 is minus 1 minus x1, which is 2, all squared. So we are simply going to have the distance will be 3 minus 5, and that will be minus 2, all squared, plus minus 1 minus 2 will give us minus 3, all squared. So this will be the square root of minus 2 squared is a positive 4, plus minus 3 squared is a positive 9. Therefore, the distance from A to B, the distance AB, will be 4 plus 9, which is 13. So our answer will be root 13. Of course, it's always good you leave your answer in the short form, root 13. So it means that if we are to find the distance from A to B using the distance formula, we are going to have root 13. Please take note of that. It's that simple. But if you want to report what root 13 is, root 13, which is the square root of 13, will simply give us 3.6. But of course, like I said, you always leave your answer in the root form. So that's how we find the distance between 2 points A and B mapped on space. All right, now that you know how to find the distance, sometimes they will give you A, B, and C as the points that make up a triangle, and you'll be asked to find what kind or what type of triangle it is. So all you need to do is to find the distance between the 3 sides of the triangle, AB, BC, AC. From the answers you have, you'll be able to determine what kind of triangle it is. Let's see how we can do that. All right. So the distance formula can also, be used to determine the type of triangle that is coded. Say, for instance, you might be asked to say the vertices ABC of a triangle are, A is on the point, let's say 2, 5. B is on the point, let's say 3 and 7. 3 and 7. And C is on the point -1 C is on the point -1 and maybe 4. Now you can be asked to find the vertices ABC of a triangle like this. Find the type of triangle ABC is. Alright, so we want to find the type of triangle ABC is, given the vertices of this triangle. And of course, for you to know the type of triangle it is, it means we want to find the 3 sides of the triangle by simply applying the distance formula. Okay, so let's see how we can do that. Let's see how we can do that. Now, from the result you have, you'll be able to determine the type of triangle that is. Okay, so this is a triangle. This is a triangle. Let's say this is a triangle A, B, and C. We want to find out what triangle it is. A, B, and C. So A is on the vertex on the point 2 and 5, and then B is on 3, 7, and then C is on -1 and 4. So with this, we'll be able to know what type of triangle this is by simply looking for AB. After that, AC. And after that, BC. With that, we will know the type of triangle it is. Okay, so first and foremost, let's look for the distance. The distance from A to B. The distance AB. Of course, we know the formula is what? y2 minus y1 all squared plus x2 minus x1 all squared. That's how it is. Okay, so A here and then B here. So we want to pick out AB. A 2 and 5 and then B 3 and 7. And please don't forget, this is still x1 y1 and this is x2 y2. So we need the distance from A to B, which is the square root of y2 minus y1. What is y2? 7. Minus y1. What is y1? 5. All squared plus x2. x2, which is 3. Minus x1, which is 2. Are you watching? Alright, all squared. So we are simply going to have the square root of 7 minus 5. That will be 2. All squared plus 3 minus 2, that will be 1 all squared. So we are going to have the square root of 2 squared is 4 plus 1 squared is 1. So the distance AB will simply give us root what? 5. That's because 4 plus 1 is 5. So we have root 5. So we'll come to the triangle distance AB and report root 5. We have been able to compute the distance AB. We are done with that. So we can now find the distance, another one, distance AC. We want to know what the distance AC is. So our distance AC, of course, we said is the square root of y2 minus y1 all squared plus x2 minus x1 all squared. So we need to bring out A and C. A and then C. We need to bring out A and C. So our A, we still have 2, 5. And then our C, we have -1, 4. And don't forget again, we still have x1, y1, and then x2, y2. So our distance AC will be equals to the square root of, what is my y2 there? Y2 is 4 minus y1. Y1 is 5. All squared plus x2. x2 is -1 minus x1. x1 is 2. All squared. So we are still simply going to have 4 minus 5 is -1 all squared plus -1 minus 2 will give us -3 all squared. So we are simply going to have -1 squared is +1 plus -3 squared is +9. So this gives us root 1 plus 9, which is root 10. So we've been able to calculate the distance AC as root 10. we are done with that side. So we still need to calculate this one, the distance BC, as the last one. So the moment we find the distance BC as the last one, it will be easy for us to know what type of triangle it is. So distance BC. The distance BC, we are bringing out our B and we are bringing out our C because we want to find BC. So B is 37 and C is minus 1, 4. Okay, as usual, this is still x1, y1, and this is x2, y2. So your distance from B to C will be equals to the square root of y2, which is 4, minus y1, which is 7, all squared, plus x2, which is minus 1, minus x1, which is 3, all squared. So we're still going to have square root of 4 minus 7. That will give us minus 3, all squared, plus minus 1 minus 3 minus 4, all squared. So we are actually going to have the square root of minus 3 squared is positive 9 plus minus 4 squared is 16. So it means we are going to have the distance BC to be 9 plus 16, that's root 25. So we report here is root 25. This is that simple. Now, at the end of this now, you can be able to conclude that the triangle is scalene triangle. Why? Because the three sides of the triangle are not equal. Please take note of that. So the triangle is scalene. But if at the end of the day, probably maybe we had 25 here, and we have root 25 here, we now have root 10 here. Now, root 25, root 25, root 10 means we have two sides that are equal. Then we can now conclude that the triangle is isosceles because it's an isosceles triangle that has two sides equal. But let's say we calculated, we had root 25 here, we had root 25 here, and we had root 25 here. The three sides, root 25, root 25, root 25. We can then conclude that the triangle is equilateral. So take note, the three types of triangle there, either be scalene, where the three sides are different, isosceles, where three sides are equal, or equilateral triangle, where the three sides are equal. So it all depends on what you calculated as the distances in the three sides of the triangle. Please take note of that. But sometimes you also find out that the triangle itself is right angle. Sometimes the triangle you have my right angle. Say for instance, in this particular one, the triangle is not right angle. Why? Because the square of the longest side is 25 equals to the square of the other two sides. The square of this is 5 plus the square of this is 10. And of course, 5 plus 10 will not give us 25. But where the longest side, let's say for instance, the longest side was 25 and here was 15, here 10. By the time you add this to this, it gives us 25, 25. It means 25 will be equal to 25. We can now conclude that this triangle is a scalene right angle triangle. Why? Because the three sides are different. That makes it a scalene. But they also satisfy, the three sides satisfies what we call the Pythagoras theorem, as I've taught before now. So you can now say the scalene triangle is also right angle. But in this case, this scalene triangle is not right angle because these three sides do not satisfy the condition of Pythagoras theorem, which is that the square of the longest side, which is the hypotenuse, is equal to the sum of the sides of the other two sides, which is the opposite, the adjacent. Please, this sounds strange to you. Don't forget to scroll through my slides, my videos, and look for the use of Pythagoras theorem to solve problems. You understand what I'm talking about right now. But so far today, we are concentrating on just for distances. And from what we have calculated, you have seen that the sides are not the same, and so the triangle is a scalene triangle. And like I said before, if two sides are equal, you will say the triangle is isosceles. But if the three sides are equal, you say that the triangle is equilateral. Thank you very much for watching this slide. Please, if you enjoyed our video, simply click on the top of the like. And if you have not, any chance, subscribe. You have not subscribed to our channel, Please don't forget to click on the red subscribe. And God will bless you as you do that. All right, until we meet again, my name still remains Mike. God bless you. Have a